Good morning, good afternoon. Welcome to this webinar on manufacturing intelligence. My name is Vidar Gunners and I'm going to walk you through the slides and the presentation today. Let's get into it. In WATS, we're focusing on your test data. That means everything you do with your product as you build them throughout manufacturing. And it's both repair data and the test results from all the tests. It doesn't matter if you're doing internal production or you use subcontractors spread around the globe, or as most companies have, is a mix of those. It doesn't matter. What makes it very easy to connect to all of these sources, and I'm going to get back to that in a little while. We also record all kinds of test data, burn-in, functional test, AOI, in-circuit test, and so forth, or others. Everything that you do can be recorded and used inside of WATS. We're also going to touch on external applications or add-ons that may give you more control. There are tools out there like ERP, MES that some of you use, but we're gonna cover some of the additional extensions to WATS like asset management and software distribution and so forth. The point is you don't have to implement all of this at once, but WATS allows you to grow over time and expand and scale up as your company grows, but also in terms of the data sources that you would like to add to it. So what is test data management? For one, it's easy access to data, so no matter where the data is coming from, what makes it very easy to connect to it and read and understand what's going on. You don't have to do a lot of configuration. The necessary information that you need are found on the test logs anyway, and we use this to give you an insight on what products you're building, what are failing the most, etc. For some customers, what's helped them to save a lot of time just finding the results when you actually need it. So that's one important part of it. Another one is to get a global overview of what's going on right now. It makes you able to follow up on quality concerns that you may have, and make the right priorities and act on those. So you can schedule or set up dashboards. They can be automatically updated with the latest information. Create dashboard per site, per product group, or basically the type of view that you are interested in. The next point is to act on those results. So inside of WATS, there's built in a method to go from high-level information and down to the actual root cause, to be able to find the problems and make changes, implement those, and improve over time. Another one is traceability, to see what has happened to the actual products, how many times have they been tested, have they been repaired, what is the connection between units, do you have a module with sub-units inside of it. The traceability system allows you to find both top-level modules and low-level subunits by using either serial number, so either the top level or the subunit information. So an example could be that you scan a module, you get all the test results for that product, but you can see that this top level unit has had a PCBA that has been replaced because you have 2 units being tested as part of it. And then to bring it all together, it's about continuous improvement. Act on the biggest issues first, fix those, and move to the next one. So it fits well if you're using Six Sigma or Lean or those type of systems in order to follow up on your production. So what are the typical challenges that you have when you are building products around the globe? Well, one of them is all of you have a lot of different data formats. Some of them comes from the machines or the instrumentation that you are using, like an in-circuit tester or an AOI system, because they have their formats already configured. There's really not much you can do with it. And then a developer who builds a final function test system, he will find his own format, maybe in a database or a flat file, etc. But the point is, what brings this together, and when you have the data connected inside of WATS, you don't have to worry about what type of test they're coming from, what is the original format. It will all look the same. You will treat all the analytics and statistics the same way. Another one is the delayed, maybe intermittent data collection. Network goes down, or there are manual procedures involved to get you the data. So that's something that the WATS client will handle for you in the background. So if there are network outages, then the client will figure this out itself and transfer the data that has not been already sent. We see that some customers are having issues getting all data from subcontractors. WATS makes this very easy to get live data from subcontractors and allows both subcontractors and the OEM to communicate based on facts. I mean, it will be a very transparent way to work with the data. Both of you can see the same thing and act on and find the real root cause. Sometimes it's with a subcontractor, other times it's with the product design or the limits or the test system, etc. But it is really a way of having you see the same data and work from the same starting point. Another issue that most companies have is that, of course, when it's a manual procedure, finding data, following up on issues, problems are found too late, and maybe it's even your customer who discovers design flaws or issues with a particular product. So WATS will help you find the problems when they occur as early in the manufacturing as possible. We'd like to record data from all the phases from start to finish. There's a 10x cost rule that says that if you find the issues a process later than the previous one, it will cost you 10 times as much. And typically, if you have to open up a unit, take out the PCB, repair it, put it back in, it is very time consuming and of course very, very costly. So information at your fingertips together with alarming and other tools allows to shorten this process. Another one that we see is some customers are focusing on, well, we may say irrelevant data. For instance, if you use like an SPC package to analyze data, you will get alarms on every data set. So what some companies are doing is that they are limiting what they're actually looking at down to maybe a few KPIs. However, if you have 1,000 test parameters and you're looking at 5, you are certainly going to miss a lot of actual root cause situations, because you are basically looking at things that are going along nicely. So we want to turn this around. We'll be very pragmatic. We'll start with a high level information and work down into the root cause, and I'll show you how it works in a second. Also, if you build tools yourself, I'd say our biggest competitor are customers who put data inside of a database and they write queries and display information in Power BI or what have you, and basically looking at segments of the data that are not really of relevance. Yeah, and that brings me on to the next point. Maintaining homegrown custom solutions. It takes time, it takes manpower, and if that person leaves the company, you're basically left with a solution that are bound to stop working at some point. So WATS provides an off-the-shelf solution to the data that you store from your test programs. Okay, so let's look at an example on how test data management works. You may create some dashboards, or you may look at a yield report, which is a high-level overall report on a specific segment of your data, maybe a factory or such. So here is such an example. It could be a dashboard component. It shows my top runners. So I have 4 products in this case. I can see the count on the right hand side. So my top runner, I have 2,367 units built in the last period. This could be a week or a day or a month or whatever. And my pass count in this case is 2,063 units, which gives me a yield calculation of 87%. So I have a lot of units failing the test. There's about 300 units failing the test. So I want to investigate why are so many of these units that I'm building failing. Alright, so what I'll do, I click this and I will get my top failures for this particular test. So here they are, and on the left hand side the biggest bar shows the test that's failing the most. It's failing around 50 times, and it counts for, if I follow the first dot here on the left hand side, it fails, well, it counts for around 25% of all the failures. Top 4 counts for almost 70% of the failures. So this is the area that I need to focus on. So let's click the first one, the Island read current load off. This is the test that is failing the most. It will show me the actual data from that test. So here in this picture you see my high limit and my low limit down here in the messy data. So these all the failures here are against the low limit. So it's as you can see, a little messy picture, but in WATS I have a method and a way to help you navigate further into the information, because hidden in here, if I show them per test station, I can see that test station 1 and 4 are nicely inside of the limits, whereas test station 2, 3, 5 and 6 are outside the limit, and they're the ones that are failing in this case. So all the results that are causing my bad yield in this case are those 4 test stations. So then I need to figure out, do these test stations need calibration, or maybe even the limits are wrong in this case. But it gives me a very quick way down into the data and the root cause. This whole process takes a minute or so. So that's one example. Another example is to have a look at your test limits, your overall test limits. So let's see here. So here's an example. You can see your limits as these red lines, and you can see the data variations coming from the different units. You can see that a couple of these guys are failing against the higher limits, so we'll be able to trap those. But in this case, the limits are so wide that it allows for these outliers to be hidden in the data set. So having a lot of these could indicate problematic products and quality concerns that you will experience later on. So WATS again will help you find this in a very easy way and make sure that you are in control of your limits, not just as you release the product and you ramp up, but over the years. These limits tend to live their own lives and are never looked upon again, but WATS will help you have control and make sure that you are running the test with the correct limits. Another issue is retesting. Why, how often, how much does it cost? So here's a simple report, and I can see basically how many times I'm retesting products. So this could be per month, per week, per year, etc. But it shows me that of the products that didn't pass in the first run, I have 500 units that passed in the second try. I have almost 100 units passing in the third run, and I have 50 units passing in the fourth, and I even have units passing in the seventh try. I don't think you should have products passing in the seventh run. It may be showing some instability, maybe of the product or the test stations or an operator who can't perform their task, but it's certainly a quality concern for you. But it also represents money. So in this next report here called cost analysis, I can set a retest cost per hour. I mean, you can choose whatever currency and value as you please, but here's an example, setting 100 euros. I run this on all my production. So here it is listed per month, and I have calculated the average time between two products. So that includes the time it takes to test the product and the time it takes to connect another one. And then it shows me, based on the total number of retests I have, what is the average cost that I'm spending on retesting the products. So a simple indication, I have about 24,000 units per month. I run 2,700 retests per month, and with €100 cost per hour, it gives me an average monthly cost of about 17,000 euros in this case. So for this year, about 200,000 euros in just retest cost, in addition to quality concerns or what have you. So it is vital that you understand why you are retesting, how much, and how much it is costing you. And especially if there are two different companies involved, you and a subcontractor, this cost is very often hidden. But putting WATS to work will be able to quickly show you how much this is costing you and how many retests there really are. And we're doing all this by including just the standard piece of information that you will record anyway from your test system, like serial number, part number, revision, the type of test, etc. You can of course add all kind of miscellaneous information if it's needed to perform calculations or communicate with other departments. But it's basically using the complete standard, the information that you record anyway. Okay, so let's extend this a little bit, because we're talking about a couple of things here: test data management, the analysis of the data, the intelligence that is built inside of WATS in order to highlight the concerns, where they are, and how and the root cause. But when you want to gain more control, if you're following like Lean or Six Sigma, there's certainly aspects of your manufacturing that could benefit from taking a step further in controlling these processes. So let's have a look at a couple of these. One thing is to add repair information. We usually say that a failed test is a symptom that something is wrong, but adding the repair information, you kind of add the actual root cause into the picture. So in WATS we do have an operator interface where you can create a repair report. You connect it to the failed test, to the actual step that caused the fail, and then you choose the type of code and maybe the component that were part of this repair. If you are already recording this information in other systems, we can of course connect to those using an API or exchange by XML files the necessary information. But it's very important that you have this in the same system. And I have to say that the de facto standard out there is having this in multiple systems. Alright, the next one is to control distribution of the software that you need on the test station. So an example is that you build a package on your master server. It could contain things that are vital to the product itself, like firmware, limits, documentation. And then on the client side, where you run your production, it will request data if it needs it. So if it subscribes on particular package, it can check if it has the latest package, and the data will be transferred. So using this schema, you can guarantee that you are up to date with the latest released software. You can have many different packages. You can have packages related to the test station. There could be drivers, a test sequence, or the individual test programs, and then things that are related to the actual products being tested. Basically, you decide how this will work. But having this method in place, or this mechanism in place, will make sure that you are in control of distributing the software. So no more email to somebody you used to know that is responsible for installing the software on 20 test stations. So here's an example of the configurator. So in the middle here I have a package called CMTH300. So it has sequence files, it has some standalone programs, it has some test VIs. So here are the test VIs, and then so forth. Another part is managing assets, making sure that the test instrumentation and fixtures, etc., are up to date or within inside calibration interval and maintenance intervals. So here's an example showing a DMM. I have a calibration day set and a maintenance day set. On fixtures you can set counts, so how many connections, disconnections are you allowed to make, so that the test system itself can check if this data is inside of the limits that you have set, and yeah, basically you can get alarm if you are outside the boundaries that you are checking against. There's of course a big REST API that allows you to connect to external applications. So there may be dashboard tools like Tableau or Power BI where you want to visualize the statistical information from WATS, or there may be other types of tools that you are using for analytics or machine learning, etc. Well, in common for all of these is that they can use the REST API to retrieve the data or update information back into WATS if needed. There's an alarm module that allows you to specify individual alarms. It could be related to measurements, it could be related to a yield. So here's an example showing if first pass yield is below 95% 3 days in a row, then you would like to get an alarm, and you can specify who is going to get this alarm so that you are not bugging all users with tons of alarms. You set your individual alarms and who's going to receive them. There is a MAC address and serial number management system built in that allows you to define ranges, and the different testers that uses these ranges can reserve certain values, and you notify back when they are taken. That will make sure that you are not reusing, for instance, MAC addresses, or you can define also custom ranges for serial numbers, so WATS can handle the management of your serial numbers. There are also what we call unit verification rules, an area where we are investing a lot in moving forward. But one thing is the actual test results, evaluating what's good and bad, but there's also the notion of making things in the right order and not allowing for retesting, repairs, etc. So here's an example. I tell that these serial numbers should go through a certain number of steps to be okay, and here's an a unit verification report from an individual unit. It's grade A because it has passed the 4 tests that I've configured for this particular one in the right order. So it did installation test, and then pre-burn-in, burn-in, and final function test, and all the test results are good, so giving grade A. But we are able to tell you that things are being done in the right order as well. So maybe as an alternative to MES, you can gain some insight on the products without having to invest too much in the MES software tools. When it comes to deployment, there's basically two main versions. Most customers are using the standard cloud option. It's Microsoft Azure. You choose the region, Asia, Europe, the US. It's being maintained by us. It's upgraded, updated with new versions a couple of times per year. And then we have some customers that requires an on-prem solution, and that means you have to maintain systems infrastructure yourself. We install the same application on your actual servers. I put a third one in between here, calling it private cloud, but it's basically a way to show we can do any combination of these. So some customers have a local server on factories in China, and they use a main cloud in Europe. So we can make all kinds of connections between the different databases. But in the middle here is definitely some custom setup that needs to be performed. Yeah, well, you can ask us about this if there are special concerns or security reviews, etc. You need to work with us on. We have a lot of experience on performing those, so it shouldn't be any problem moving on that. All right, so here's an example then on how all of this are coming together. So a little picture of the globe. We install this WATS data client on the different sites that you may have. So the WATS data client is a little software that runs on your test machine or a central machine connected to the internet, and it's responsible for sending data from the test station to the WATS server. So it has built-in offline support and will handle all of these housekeeping functions if the network goes down or if there are any issues. Okay, so on the left-hand side, we need to connect to your test system in one way or the other. So how do we do that? First option is to integrate it into the actual test software. So here are some examples. If you're using National Instruments Test Stand, there is a plugin architecture already, so you can just enable WATS and it will start uploading data. Then if you are using a programming environment to build your own test sequence, you can use the APIs inside of LabVIEW or Visual Studio or any other programming language to send the data to the WATS data client. So that's one way. Another way is to use our standard formats. So if you start from a fresh new development task, you can choose any of these formats that are open. They just record the necessary information like serial number, part number, name of test, the value, the limits, etc. Yeah, you just store them in a folder where the WATS data client is monitoring, and it's fire and forget. You just store every new file in that folder, and the system will handle the rest. The last option is to connect to any type of custom format out there. and that's a lot. I mean, there are CSV files, there are XML files. Some customers use databases, some use databases in the cloud, etc. And for those, there's a way to create some custom converters in order to process that information rapidly as well. And it may be a quick thing to do, or it require a couple of days of work in order to set it up and have it work solidly. But the principle is basically the same. The data converter will read a file stored from the system, or read inside of a database and use the WATS data client and push data into the database. Alongside this, there's also the REST API, so you can use the REST API directly yourself and push data reports into WATS using a JSON format or XML. So if you're using Python, for instance, on a Unix machine, Linux machine, you can use the REST API directly and push those test results into WATS as well. Okay, so then data is transferred to the database. Although we're talking mostly about Azure, I just want to make the point again that it's the same application, the same WATS software that runs on-premise as well. All reporting and analysis is done through a standard web browser, so a design choice we made many years ago to avoiding installing applications on the user side, which makes it very lean. And that goes for the left-hand side as well. It's very lean when connecting to the test station. We just want access to the data somehow. Okay, so some customer put the code inside of their framework. However, if we can get access to the data somehow, that's all we basically need. Yeah, I just want to mention the REST API again. You can of course read data from the database using our Android or iOS apps. Just make sure that you search for WATS Virinko, otherwise you may find a popular chat application. Yeah, and use the same REST API then to connect to your other custom tools that you're developing. Okay, so that was the whole picture. That was what I wanted to present to you today. If you want to try, please go to wats.com and request a free trial. We'll set it up in a few minutes and you have live data streaming to your demo account. You can do statistical analysis and you can get the root cause analysis almost instantly by signing up here. And then the next step will be to get some of your data connected, and that should be a very simple task as well, to see what insight we can provide on your data. Okay, so that sums it up. Any questions that you may have, please, yeah, you can leave them in the chat window, or send us an email. Send me an email, vidar@virinko.com, or go to wats.com and fill out the contact form. So with that, thank you all. Have a great day, and I'll see you later. Thank you. Bye.